Thank you for watching this video. Now today in this part of the lesson, we are going to look at some of the information that we can extract from a stem and leaf diagram. What are some of the data that we can extract? Namely, usually the first one we can find the range and then the three different measures of central tendency, mean, median, and mode. So now let's take a look at our stem and leaf diagram over here. For our stem and leaf diagram, a typical stem and leaf diagram, we must always take a look at their key, right? So what does the stem and leaf diagram actually represents? Now this one is 194. It actually means it represents the data 194 grams. Now sometimes there can be some data that can be raised. For example, instead of 194, it can represent 194 with 3 zeros in terms of thousands. Alright, or it can represent 19.4 in the decimal place. So it's still important to read the key. If not, you get the answers, but then the accuracy of the answer will not be correct. Alright, depending on the stem, the key itself. Right, now the first data that we're going to look at is going to look at the range. So range is actually given to be the maximum value minus the minimum value. So range in this case, our largest value will be the number 228. Subtract our smallest data value 191. That will give me 37 grams. Up next, we can also find the median. How to calculate the median? Now to calculate the median, first we need to count the total number set of data that's available. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's a total of 20 data sets over here. So in this case, in order to calculate our mean, we should calculate the middle position first. So our middle position will be given by taking 20 plus 1 divided by 2. And that gives me the number 10.5. What does this mean? It means that I'm taking the 10th number and the 11th number, taking the average of these two numbers. Right, so let's calculate the 10th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th number is the number, not just the digit 8. That's the leaf, so we need to include the stem. So the median will be given by taking the number 208 plus our 11th data value is 210. So that will be 210 over 2, and the median will be 209 grams. Have you gotten the answer? Next part of the question, question is talking about the modal mass. What's a modal mass? Modal actually means the number that is repeated the most often. Now there are some students who will actually tell me, sure, the number 7, the leaf 7 is being repeated a few times. But in this case, is that really true? Well, the number, this leaf over here, this 7 actually belongs to a stem 20, but this leaf over here belongs to the stem 217. So technically speaking, these three data values do not belong to the same stem. Right, only the two of them belongs to the same stem. So we're going to look at the numbers, the data values that appears very frequently, or like the one with the highest frequency. So let's take a look at what are the numbers that has a higher frequency that repeats itself more times. So first one, we know the 217, right, repeats itself, but is that the only mode in this case? Well, I have the number 5 in the same stem, 195, to repeat itself 2 times as well. Is that all? I also have the number 208, the stem 208 in the leaf, right, to repeat itself 2 times. So in this case, our modal mass will have 3 different modal mass. Okay, namely, our modal mass will be 195 gram, 208 gram, and 217 gram. There will not be only just one mode, there will be more than one, so of the same equal frequency. So we need to write all 3 of them. Right? Next part, we're going to calculate the mean. What do you mean by mean? Mean of a data is actually the average, where you take the sum of all the data values. That means you add up all the data multiplying with its frequency, divide by the total number of sets of data, the total frequency. Now we calculated just now that our denominator, the total frequency, there are 20 leaves down there. So now we're going to calculate the total value. So in our examination here, if there's no algebra involved in this case, we can use the calculator to just simply calculate the numbers. So what we'll have 191 plus 194. Okay, this one is 194 plus 195 times itself 2 times. That's why the data value is x times the frequency, right? Plus 200, 203, plus 204, plus 207, 208 appears 2 times. So we multiply by a frequency of 2, plus 210, 211, 214, 217 times 2, 218 and 219, plus 224, 226, and finally 228. I get a total of 4189. So I should just write down the working 4189 over here. For our papers, when you use a calculation, so this is the only way that you can show your working, right? This working itself usually carries 1 mark if your mean is 2 marks itself. But if the mean is just 1 mark, then there'll be no value, no marks for it if you don't write the working, alright? And then next one, we're gonna divide this by 20, and we get the number is 209.45 grams. Now this is an exact value. Please do not round off the value. Alright. Now in general, we can find the following data from a stem and leaf diagram: the range, the median, the mode, and the mean. So under normal circumstances, when we take measurements of central tendency and we need to compare data, we will usually choose number 1, the mean first, because it involves calculations of all the data. The second one will be the median. It involves some calculations, like for example 208 plus 210, but it only for some of the data, but it will involve the rearrangement of all the data set. It needs to be in order, okay, rearranged in order before you find the median. Then the third one will be the modal mass, the mode, right, which is your popular frequency. But out of these three, the one that is usually the most accurate will go with the mean, followed by the median. And we seldom use the mode to make our comparison. For example, like in this case, we have 3 modes. So which data value are we going to use as the mode itself? So the better measures of central tendency is usually the median or the mean. But then there are some special cases that we're going to look at later where the mean may not be a good approximation of the measures of central tendency. That is because of certain special cases such as the outlier. Now we should move on to look at the next case. Question number 2. A group of students took part in a selection race to qualify for a 100-meter race during sports day. The stem and leaf diagram below shows the time in seconds, right? So some of the units we need to take note of in seconds, taken by a group of students to complete the race. Now, first thing to take note, look at the key. So we have our key down here. What does this mean? 11/3 actually represents 11.3 seconds. So this is what we mean by looking at the key itself. Sometimes can have different sets of representation, not always going to be 113. Alright? So now first question, find the range of time taken by the students to complete the race. So we all know that range is equals to the largest value. In this case, is it 135? No, it's 13.5 seconds. Subtract away the smallest data value, which is 11.3 seconds, right? And this gives us 13.5 2.2 seconds. Alright, Next one, the top 5 students were selected to compete on sports day. Find the minimum time that you need to qualify to clock and qualify for the 100-meter race on that day. So only the top 5 students. Now usually when we have looking at data stem and leaf diagram, for example like marks or other set of data, we want it to be as large, the value to be as large as possible to be considered good. But in this case, this one is clocking the timing for running a 100-meter race. Do you want values that are large values, or do you want values that are smaller values? Do you want timings that take a longer timing or timings that is shorter? Well, in this case, due to the situation, the story, the scenario itself, we are going to choose the top 5 students instead of instead of looking at the larger values from the bottom. We are going to look at the top 5 students with the lowest time, the shortest time possible. So this is 1, 2, 3, 4, and 5. So the cutoff timing is actually here if I want to qualify for the 100-meter race. So in this case, the qualification time, they say the minimum time. So it's like a minimum criteria, right? So my time taken that I need to qualify for this, to qualify for it, will be 11.6 seconds. So 11.3 seconds. Right? This kind of question will only have 1 mark, no mark for working, so just based on interpretation. Next one, find the modal and the median time. What's the mode? The mode is the data value that appears the most often. So I'm going to erase this away a little bit so that I can have working. Right, so we're going to look at the mode. Which number appears the most often? The most number of times. So we have this one, that will be 1 to 12.0 second. So the modal timing, mode will be 12.0 second. And we're going to find the median. Now, how many students are there inside this median? How many data set? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Again, it's total 20 data set. So if you want to get a data set of 20, let's find the middle position. The middle position will be taking 20 plus 1 divided by 2 to give me 10.5. So I want the 10th value and the 11th value. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th and the 11th value. So now our 10th and 11th value are both 12.0. So our median timing will be 12.0 plus 12.0 divided by 2 is still 12.0 seconds. Right? So I chose not to write the working. Okay? Next question. If each time is increased by 0.1 seconds for students in group A, what does this mean? This means every single timing is added by 0.1 second. How will the mean be affected? If I have an average, all the data values to increase by 0.1, that means my mean will naturally also increase by 0.1 second. This effect is also the same for my median. Alright? Okay, this effect will also be the same for my median. But this effect may not be the same for range. But anyway, let me answer to the question first. The mean will increase by how much? By 0.1 second. Okay? Similarly for the median is on the data value itself. So if every data increases by 0.1, all my median will also increase by 0.1. However, this effect is not true when it's on my range. So for example, our range down here is 13.5 minus 11.3. So if every single data value is to increase by 0.1 second, this largest number will become 13.6, and the smallest value will now become 11.4. After doing a subtraction, okay, you will still get back the number 2.2 seconds. So, right, it's because the numbers they subtracted away themselves, right? So in this case, when you have every data value to increase by 0.1, the range will be unaffected. It stays the same. Only the mean or the median and the mode itself will increase by 0.1 second. Have you gotten the concept? Question number 3. Now in this example here, we're going to look at this thing called a back-to-back stem and leaf diagram. Back-to-back. Now a back-to-back stem and leaf diagram has a fixed stem right in the middle. These are all the different stem values, right? And then the leaves will branch out from the smallest to the biggest. The smallest leaf that is being the one near to the stem itself. So when you have for the boys the side of the data value, right, the smallest data will be on the side that is nearest, okay, to the stem, and then the larger value to the big value, the larger value will be away from the stem itself. So you have to know how does the stem and leaf back-to-back stem and leaf diagram data value works. So in this case, for example, if I have a number that looks like this, 4 and 1, 3, right? This can be read as the stem is 13, 1, 3, and the leaf is 4. So this data value is actually 1, 3, 4 instead of 4, 1, 3. Similarly, if I have a data value that says, for example, like 417, it actually means the stem is 17 and the leaf is 4. So it means 174. Right? So before we begin, we need to make sure you know how to read the stem and leaf diagram, the values itself. Right? Next question, let's begin. There's a boys and there's a girls. So when you write your working, right, you need to label them very clearly. Okay? Given that the range of height for boys, the range of height, what is range? Range is taking the maximum minus the minimum. So that's the range, right? So what do we have for our range values, right? And they gave me that this is 42, right? Let me just erase this again. What is my range? Range is given by my maximum value. In this case, my maximum value is 17x. So there's a maximum value. I do not know what is this data value, x. X is that leaf. Minus away your minimum data value. The minimum data value is 132. Is equals to the number 42. So what is this maximum data value? This maximum data value will be 42. You bring this over, plus 132. And that gives me the number 174. Correct? But is 174 the answer? The question wants the value of the x itself. X is just the leaf. The stem is already 17, so therefore x is the leaf, which is 4. So what is the answer for the value of x? X is equals to 4. Okay, have you gotten the concept? So please take note of such little tricks in the questions itself. Next one, we're going to calculate a percentage. Find the percentage of children that is shorter than 170. Does it include 170? No, right? So it doesn't include 170. Next one, this one, the general word down here is percentage of children. Is it talking about male, female, boy or girls? No, it's talking about everyone. So I want to find the data values of every child that is shorter than 170. But before we begin, we need to know a total values. How many boys and girls are there in total? Is it the same? Let's calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 girls. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 boys. How many children are there in total? So 12 plus 14, that's a total of 26 children. Now I want the children that are shorter than 170 cm. So shorter than 170, that means cannot include 170. So I'll have all the data values. Wow, so many. Right, so I have a total of 26, minus away 1, 2, 3. Minus away 3 data value, that will give me 23. If not, I shall count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So there are 23 values, okay, who are shorter than 170 cm. So this one will be 23. We are looking for a percentage out of the total. So 23 over the total times 100%. For values in fraction, we try to leave them in terms of fraction for exact value, or you may get a large decimal place. So in this case, I will have 88, 6 over 13%, an exact value. Try not to round it off to 3 significant figures. Okay. Next part of the question, explain why the mean may not be an appropriate average to summarize the height of the girls in this group. What's wrong with the data set? Let's take a look at the data set. Majority of the data set, or most of the data set, starts from the height 138 all the way to 170. This is the main bulk of the data. But however, there's a special data 101 that is extremely short. This is an extreme value. Okay, what we call it this an extreme value. Okay, it's either extremely small or it's extremely big. So in this case, it's extremely small. Or another special name for it, we can call it the outlier. What do you mean by outlier? Means the data that's very far away from the rest of the normal, the standard group itself. So this extreme value, be it being a very small value, it will greatly affect the mean. It will pull down the average height of the girls to be a smaller value. So since there's a case like that, this mean will not be an accurate representation of an average. So explain why the mean is not a good average. There is an outlier. Or you can write extreme value of 101 cm, 101 cm. State the value itself. Alright, there's an outlier option of 101 cm. These values greatly, in this case, this is a small number, it will decrease the mean. If I have an extremely large number, it will increase the mean. So this value itself greatly decreases the mean. So therefore, it is not an appropriate average to summarize the heights. Okay, have you gotten the concept? So now usually in this kind of cases, right, we will, by right, the first one we will use a mean. Then if in this case the mean cannot be used, what should we use to compare data? What's the next best central tendency or the next best appropriate average? That will be their median. So if the question asks you to compare data value, you need to find the median, right? Part D, find the median of boys' height and the median of girls' heights respectively. Now please take a look. In this case, they have a different total frequency. So one is 12, one is 14. So if I want to find the median, I'm going to calculate the middle position for the men, for boys instead. The middle position will be there are 12 boys plus 1 divided by 2. That gives me 6.5. So the median, since there are two data values, please label clearly. Median for boys itself will be the 6th and the 7th value. Okay, starting from the smallest. So 1, 2, 3, 4, 5, 6. The sixth number, this is 148. And the 7th value will be 149. Right, according to our stem and leaf diagram. So 148 plus 149 cm divided by 2. And that gives me 148.5 cm. Okay. Next one, what is the middle position for the girls? The middle position. There are a total of 14 girls over here. So 14 plus 1 divided by 2 to give you 7.5. Okay, so that you take the 7.5 position. So the median will be taking the 7th number. 1, 2, 3, 4, 5, 6, 7 number. And the 8th number, 160 plus 163 divided by 2. And that gives me 161.5 cm. Okay, this is accurate. So this one is median for the girls. We need to label it properly. Then down here, we're going to compare which group of students is taller. You're comparing the male and the female, or the boys and the girls, right? And we need to state a reason why. So now, which measure of central tendency are we going to use? Are we going to use the mean, or are we going to use the median? So since the mean that is outlier, right? So it will actually decrease the mean. So we're not going to use the mean. Right? So we're going to use the median for comparison. If I use the median for the girls, then I must also compare with the median for the boys itself in order to be fair. So now what do we notice? We notice the median for the boys' side is 148.5 and the median for the girls' side is 161.5. Right? So what does that tell us? Right? Then we write down the evidence. Since median for the girls, right, is equals to 161.5 cm greater than, so you always comparison what? Greater than the median of our boys. State the value, okay, 148.5 cm. State the value here. Since this is true, okay, which group of students is taller? Therefore, make a conclusion. Girls are taller. Okay, not in general that girls are taller, but in this group of data, the girls are taller. Okay, with that, we've come to the end of this part of our lesson. So just to recap again, usually for measures of central tendency, the first best way to calculate is to use the mean. Then followed by the median, and the last but not least, then the mode. But if in this case we have like an outlier, then the mean itself may be greatly affected, either increased or decreased. So then in that case, we should use the median for comparison. When we compare data values, always make sure you give the evidence. Okay, give the numbers, quote the numbers, compare the data, and then make a conclusion. Alright, have you gotten the concepts? Now we come to the end of this part of the lesson. I'll see you for the next lesson. Bye.